welcome to the webinar on Convergence of Design to Advanced Manufacturing, a discussion to explore manufacturing-ready outcomes earlier in the production process, which is organized by Manufacturing Today and presented by Autodesk. Now, Manufacturing Today is a part of ITP Group, which is based out of Dubai, and in India we have around um, eight titles wherein we cater to hotelier industries, architecture, construction, manufacturing, healthcare, commercial design, and digital space. Manufacturing Today is a 12-year-old brand where we cater to the manufacturing industries from across the manufacturing sector realm, where we cover automotive, defense, aerospace, digital, IT, etc. So today's webinar is all about how we can explore manufacturing ready outcomes earlier in the production process. So in manufacturing, time is always a factor. Today, many engineers are doing work for more than one person. Engineers need a solution, find a solution or a couple and run with it. Using AI and the computing power of the cloud, engineers create thousands of options to simplify defining their process problems, inputting basic parameters. Engineers are no longer limited by their own imagination or past experiences. Instead, they are collaborating with technology to co-create more, to co-create better, and to co-create with less. More ideas and products that better meet the needed needs of users in less time, with less negative impact on the environment. So today's webinar is an endeavor to bring together manufacturing leaders who ensure the production process is safe, efficient, precise, and meets quality standards. In other words, they ensure success. The goal is to provide a friendly, confidential, non-competitive forum wherein we can discuss about all the points that we mentioned above. So without taking any further time, allow me to introduce to Arun D'Souza, who is a country manager, Digital Manufacturing Group, India, ASEAN and ANZ, Autodesk. He is a result-oriented sales leader and has over 2 decades of experience with a passion and flair to build new markets and new businesses. He's a people's person with a proven track record of building and nurturing high-performance teams that deliver results, foster client relationships to achieve organizational goals. His expertise lies in business planning, sales management, channel management, and execution. Over to you, Arun.
Thank you. First of all, before I start, good afternoon, everybody. Thank you very much for taking the time out and attending this webinar today. Okay, so first, let me introduce myself once again. I'm Arun D'Souza. I'm responsible for the digital manufacturing business for Autodesk India and ANZ. My email ID is mentioned below. I also want to take this opportunity in thanking Manufacturing Today in giving us this opportunity to present today a little bit on Autodesk, as well as I'm going to be talking on the digital transformation journey that our customers are taking. But before I start, a little bit about Autodesk, right? At Autodesk, we believe in making a better world that can be designed and made for all. And that's why we make it a mission to empower our customers and as well as the educators, as well as the innovators of the world with the software that helps them in achieving better outcomes for their projects, their products, their businesses. Here, we help our customers in terms of creating new paths to efficiency, sustainability, and growth, as well as advance their digital transformation efforts and create new experiences and value. At Autodesk, we operate in different industries and segments. So we cater to the different industries like architecture, engineering, construction, the manufacturing, and the media and entertainment space. So there's a saying in Autodesk that if God has not created, it's either created using some of the Autodesk software by our customers. So we kind of reach across multiple industries, uniquely support our customer work in what they do and how we can help them to do those things. So if you see any flyover, any bridges, those have been built using an Autodesk software. You see any automobile consumer product, I'm sure there is some of the other Autodesk product should have been reached. But last but not the least, I think the last 14, 15 years, I remember all the VFX movies which have been kind of nominated for Oscars have won or won Oscars have used some of the other Autodesk solutions, for those projects. So we also at the same time enable our customers to access value that comes in making buildings greener or making cars cleaner, factories smarter, and even making the blockbusters bigger. So that was a little bit about Autodesk that I wanted to cover today in my presentation before I to what I'm going to be talking about today, right? So every customer is unique. The products that they make are different. The people employed are different. The markets that we serve are different. Some would cater to domestic market, some would cater to an international market, or both, right? And with this, there's also diversity which comes in. So it's a very easy thing to say something like digital transformation. Something like digital transformation would have different meanings, different connotations to different people. In fact, what we see, what our customers want from us is how we can help them in their journey in making better products, or how can they sell more of them, or last but not the least, greater value in terms of how can they do all these things, in a better way, in a much efficient way. But this is what research says, and this is what I'm going to be touching upon. Like these are figures which are like research papers like Gartner, or this is a Gartner figure out here, but various other research agencies, do these kind of work. And they see that 45% of the new products are delayed by at least a month. Okay, now 45% is not a small number for sure. Second, 72% of the products fail to hit their profitability targets. Now, which means only 28% succeed. That's a small number when compared, to the products which fail. And last but not the least, we are seeing global productivity rate plateau at about 3%. Now, these are all kind of, research figures which are there for us to look and see how we can change, how we can improve. And with that disruption, comes opportunity. So there are different ways of looking at it, right? We take challenges which are disrupting what we do and how we do it. Now, for example, COVID hit all of us about 3 years back. I think it was today itself where the lockdown was announced, right? And everything changed for us. We started working from home, schooling from home, everything started from home. But despite all these challenges, there were some amazing opportunities, that exist and that got created, right? It depends on us how we look at it. You look at it as a challenge or you look at it as an opportunity. It depends on how we choose to act on that challenge and how do you want to, circumvent or, move across from that. So what I'm talking about here is the opportunity to lead your industry with smart products. Because if you do not, your competitors will, right? If you do not get your product in time, your competitors will do, or your product kind of becomes a commodity. How can you digitize the entire process? Over the last 2 or 3 years, we've seen digitization much, much more than what it was earlier. Because if you do not digitize today, or if you do not go digital today, you would lose your productivity and your profitability can suffer. And last, the entire week during COVID period, everyone spoke about resilience, right? How do you build a resilient and a flexible supply chain? Because at the end of the day, no matter how good your products are, right? If you don't reach to your customers in time, you would not hit your results, you would not hit your goals. And that is where you need to have a very, very resilient supply chain or a business model in that. But when we talk to our customers, or when we talk to any manufacturing company, or maybe customers from different industries or different segments, right? All of them say that their businesses has already been stretched. It's come to a kind of a breaking point in that sense, where there are different processes which have been broken. There are today, let's look at data, for example. There are so many multiple data formats, right? If you take our industry itself in the manufacturing, there are multiple data formats. There are so many manual systems. Half of the things are manual, half of the things are digital. There are still things like which go on verbal within the industry or within, the factory, for example. So there's a mix of everything today. There's a mix of analog, there's a mix of digital. There are different things that are there, for example, in the way we kind of do business today. So considering all of this, how can we simultaneously meet those challenges as well as address the opportunity that we have going forward? And that is where we have certain things, for example, if is it that you just want to survive or is it that you want to thrive, right? If you want to thrive, what is it that you need to look at? What is it that you can look at? So people today who want to thrive look at a fully programmed system, for example, for increasing manufacturing output, automation, and throughput, right? They want things like automation. They want things like where they can validate designs at the design stage itself. They want a kind of a depository where data can be stored and used as a knowledge base, not only now, but maybe in the future. How do you kind of have a full design to manufacturing collaboration, or I would say even beyond to an ecosystem to your supply chain? Now, these are the things what companies are looking at from a future perspective to thrive. And this is where comes the digital transformation, right? As I said earlier, when I say digital transformation, it could have different meanings, different connotations to different people, different industries, different segments. So what we see it as Autodesk is nothing more complex than looking at what you do, how you do it, and applying technology and best practices to those part of the business. So it could be either at your design stage, or it could be at your simulation, or it could be in your manufacturing process, or the entire way the data flows, whether it's from concept to design to manufacturing, the data flow that happens within your organization. Now, when you take care of all these things, the value proposition that you get also makes a lot of difference. The value proposition that you have to your people, the profits that you do as an organization, and last but not least, how we're kind of helping our planet, or how we're kind of building a sustainable business overall. I think those are also some of the important things that we have to look at when we talk of something like a transformation or a digital transformation. So what are we doing at Autodesk, right? At Autodesk, we're trying to build a solution. So for example, organizations could be of different size. It could be an organization with a single resource. It could be an organization with hundreds of resources, right? There are times where in a single organization, you have a designer or an engineer in an R&D department or in the engineering department. At times, they wear multiple hats, which means in the past, you had to have multiple products. You would have a product for concept, or you could have a product for design, or you could have a product for documentation, or for CAE or simulation or manufacturing, you could have different products. And this is where we kind of trying to build a solution which is flexible, which is kind of intuitive platform that can be kind of configured to your team size. You could have a workflow which kind of gets access not only to that particular department or division, but kind of an enterprise kind of feature. And what you can also have is intelligent tools where you have, for example, features like generative design, which at the back end uses the AI and ML to give you thousands of solutions to a problem. So it's not, you're not working on one design, but you have generative, which can help you with multiple solutions if you define, simulate the performance, give your constraints, and also what manufacturing capabilities you have. So if you give all of these things, you could get thousands of designs. And then it is up to you to choose which is the best design, which would be high performing, which would be cost effective, and a sustainable design that you couldn't have reached on your own so fast. This could take kind of minutes, but if you had to do it on your own, it could take much more time. The other thing, how do you build a kind of a solution which helps you in a kind of platform, right? Or a solution from start to end, not only about talking about the concept stage or design stage, but how do you take it to the manufacturing ecosystem? How does this data reside? Where does this data reside? How can you have a kind of a cloud-based model which kind of enables you, in eliminating the friction that is there between the different departments? How can you kind of do things simultaneously without waiting for the data for some input or feedback to come back from the manufacturing to the design department? Again, you have iterations, etc. How can you do all these things parallelly, or I would say in some terms, simultaneously, which helps you in kind of your work developing fast. So here, what we're talking about and what we're looking at is a solution which not only helps you in kind of concept, but also in kind of designing. It kind of helps you in documentation. It kind of helps you in product development, manufacturing, electronics, kind of helps your team in the entire work that he needs to do, which can also be extended beyond of your organization to your kind of supply networks or to your ecosystem, and helps you kind of accessing the latest manufacturing technologies that we have, and get in achieving the and or making the impossible possible in terms of the outcomes that we have. So what I'm talking about here is a solution that we have that's not just a CAD, that's not just a CAM or a simulation software, but a software which can help you with CAD, CAM, simulation, documentation, rendering, electronics. So it's all of these things that I'm talking about, a solution that Autodesk can offer, which can help you with all of these things. Now, how does it help you? It can help you to get your things faster to market. It can be, all those things. But at the end of the day, this solution is available to you from any device, anywhere, anytime. So we're talking about a cloud-based solution, which is device independent. Whether you work from your desktop or your tablet or your laptop, you could work from anywhere, because all the data kind of resides on the cloud, and you can, work on the go in that sense. So what we're talking about out here is a little bit away from the traditional life cycle to move to a more connected kind of a process. Now, in this process, once you start on this journey, is where transformation starts, information, for example, starts to flow throughout the organization. And the silos that we work in today, it can kind of minimize. The information that we have can kind of be reused. There are so many times we kind of do the same thing, in spite all the data already being there with us, right? So most importantly, resulting in a kind of a productivity uplift. But the journey does not kind of end here. The companies which are kind of going on this transformation are also taking it one step forward in what we call as a transformational capabilities. So kind of let me give you an example, right? What you see out here is a mobile device. There was a time when we owned multiple devices. So for example, we had a device for tracking. We had a device for example, our exercise. We had a separate digital camera, which we use for capturing our memories, or we did online banking from our desktop PC. Now, all these systems were kind of giving us different capabilities in our life of either moving from point A to point B, or capturing, memories, or doing our finances. But what happened is, over a period of time, all these tools converged into one single platform to what we call as a cell phone today, right? This is where the real transformation took place. This is what I was just talking about a little bit, a few minutes back. So suddenly today, all of us, access key applications from our mobile phone, whether it's communication, whether it is doing data, whether it's doing banking, exercising, capturing memories. We no longer look at multiple devices. So we use one device, and, this is where our lives have changed. And this is not a digital, but this is the real transformation, that took place. So what we kind of help our customers is being fast. We can help our customers, develop or deploy our solutions much faster, enable people from your organization, irrespective of different departments, access this data from anywhere in the world, leading you to a faster return. At the end of the day, when you kind of do all these things, you get products faster to market, you have a resilient ecosystem. It helps you in terms of increasing your profitability. Next, how do we help? The second principle that we help is helping our customers in terms of being flexible. right? I kind of, you know, 3 years of COVID today, and we all know about it, right? The resilience and how agile we are, which is what makes the difference. So coexisting with your existing system, so there's no need to rip and replace kind of a thing. You know, it adapts. This solution that I'm talking about adapts to the loads and demands on your business and can be customized for you to meet any specific requirement that you have. So we're talking about a product out here that has a greater resilience to increasing your efficiency while maintaining the right talent within your organization, you know, without kind of a rip and a replace kind. Last but not the least, a limitless solution, right? The final principle is that it has to be limitless, meaning it enables endless connections between multiple disciplines in your business. I kept speaking about this, which I really think is very important. It could be to a wider ecosystem also that you rely on, which is your suppliers, etc. Now, you know, we can talk about this approach, etc., or you can take a modular approach. But starting anywhere, I think, is extremely important for all our customers. You know, having that domain expertise where it makes sense, either directly or through partnership. So these are the things which are important in kind of doing that transition of your journey and kind of having those things available for you. So if I had to wrap it up in that sense, you know, for my last couple of slides, the digital transformation can help you simultaneously meet the challenges that you face today. But at the same time, right, I would say it can leverage the opportunities that exist for the future. So it's never only a technology that we're talking about or a solution that we're talking about, right? A technology or a solution can help you to some extent, but it's kind of a journey that you take on, you know, developing capabilities like this, which will not help you for today, but help you more for tomorrow or for the future. And if I had to kind of give an example of what it looks like, right? I'm not going to be talking about the expected because that's what kind of people will kind of do today. And, you know, but what I want to talk about is how customers can move on to the exceed or be the best in class, right? And I would like to spend some time here on the best or class. So today, I could talk about, you know, people using additive as well as subtractive process or D, for example. How do you do an upfront mode simulation right at the product design stage? How do you use something like a 3D printer or an additive solution, whether it's for concept or whether it's for, you know, manufacturing in that true sense? How do you use a data repository, which is more of a knowledge base, which can be used for you now and for the future, right? Now, these are some of the things where it could be really best in class. This is where the world is really moving from kind of a digital in that sense to something and things being available on the cloud. And we, Autodesk, can help you in that journey. We can help you in that transformational journey. We can help you in that journey of taking you from step A to step B, right? And if there's any way we can help, we are more than ready to help you in that transformation journey. You have my coordinates below, arun.d'souza@autodesk.com. Please feel free to reach out to me or any of my team members at any point of time. And we would definitely love and work with you in this transformation. With that, I come to the end of my presentation. Once again, thank you everyone for taking the time out for today's webinar. Thank you Manufacturing Today for giving us this platform, you know, to present of our, what we think about the digital transformation in the industry. Thank you very much.
Thanks, Arun. Thank you for the insights that you gave regarding Autodesk and how you are helping manufacturing industry. So before we begin, I would like to thank all the audiences who have logged in for this webinar on behalf of Manufacturing Today and Autodesk. Before we begin the panel discussion, we have a small poll arranged for the audience. Can we have the results? That's the revelation. Thank you. Thank you, Sri. Now I will hand over the stage to Ashok Muthuswamy, VP, PE and TQM Tafel Group. Ashok has 25 plus years of global experience in manufacturing, operation, TQM, Lean Six Sigma, analytics, SCM, business excellence, and project management. He has provided leadership to startup plants and established plants. He has revamped loss-making units into profitable entities through strategic interventions and putting effective system. Ashok has also led and implemented strategic improvement projects by applying Six Sigma and analytics through working with various cross functional teams in a global environment. Ashok, over to you.
So, thank you so much, Sujata. So, that was a very generous introduction. And I'd also like to thank Manufacturing Today for this great opportunity. And I'm delighted to discuss some of the cutting edge topics with my fellow panelists. With that, let me just have a very quick introduction. I mean, rather, let me request all the panelists to do a quick introduction. If you could keep it very light, name, title, and organization, so that we can spend more time on the questions, if okay with you. So let's quickly do a roundtable.
Hi, this is Karthik Raman. Can you hear me?
Yes, Karthik, go ahead.
Yeah, this is Karthik Raman. I head the product management and I'm responsible for the product development activities for Metal and also for the Middle East market. So I'm based in Bangalore.
Okay, thank you, Karthik. Yeah, maybe Sachin. Maybe I'll quickly read the name so it makes it easy.
Thank
Sachin.
you. Thank you. My name is Sachin Fulsundar. I am a senior technical specialist at Autodesk. I take care of the technical aspects of the simulation product for India, ASEAN, and ANZ. And I thank Manufacturing Today for this opportunity.
Thank you, Sachin. Sandeep.
Good afternoon to all. My name is Sandeep Kinkar. I'm representing Praj Industries Limited. I am Vice President Operations for Manufacturing and Critical Process Equipments. Thank you very much. Thanks, Manufacturing Today, for this opportunity. Thank you.
Thank you. Sunil.
So I am Sunil Shrivastava. I am from Uno Minda Limited Company. So I am as a business head for acoustic and speaker business. And in my previous role, I was as a domain manufacturing excellence officer. Plus, I have a chance to head the group IT department also and the group material function. Thank you.
Thank you, Vivek.
Yeah, thank you. First, I would like to thank Manufacturing Today for bringing me on this platform. And I'm Vivek. I'm working out of HCL Tech, and I'm taking care of Manufacturing Engineering Center of Excellence Group heading for various verticals, and we provide services to world's various organizations. Thank you.
Thank you, Vivek. Gajendra.
Myself, Gajendra Yadav. I am representing CG Power Industry Solution Limited. Presently looking after the manufacturing of two product line, DT and LPT transformer. We are here making electrical transformer up to 50 MVA and voltage class is 132. From last 16 years, I am heading production, quality in Six Sigma, in process quality, and cross-functional team within the team in organization. Presently, I am looking after the manufacturing. Thank you, Manufacturing Today, to provide this opportunity.
Okay, brilliant. Thank you, Gajendra. So let's now get into the topic. So I will just give you a quick introduction, not so much introduction about advanced manufacturing or smart manufacturing, but how we practice in our own organization. See, like I work for TAFE, which owns both TAFE and Eicher brands of tractors, and Massey Ferguson is our brand. So let me just give you a few snippets of how we use advanced manufacturing. And then there are some very interesting questions that I will put to the fellow panelists, and we will seek their views, and I'm sure it will be a very enriching experience. So that said, TAFE, which is one of the world's largest tractor manufacturers, here we leverage the power of digital capabilities extensively in our manufacturing so that we ensure that we produce absolutely robust products using very robust processes and deliver world-class and flawless products to our customers. And if you see, our customers are farmers, right? So if a tractor is down for a day, they lose the livelihood for a given day. You know, typically either the small farmers, or if it is a service provider who is doing the service of doing whatever the farm job, plowing, tilling, and all that stuff, they lose their livelihood for the day. So we endeavor to ensure that our tractors are always up and running and running flawlessly and very efficiently. So where we have used the digitalization extensively because all our products are designed digitally. And even the tooling is designed digitally. We can even visualize the assembly line prior to even producing a physical prototype. So once we have a digital prototype, we run it through our digital assembly line, almost like a digital twin. That helps us find out which areas the product is fouling, what fixtures need to be corrected in our existing assembly line. So even while a product is being designed, we also, to a good extent, work on process design, ensure absolute compatibility between product process. So the minute the design is over, we are very ready to go ahead and work on our manufacturing, right? That, and maybe just I will add one more example, and then I will start the questions to panelists. Even see for as you all know, most of the automotive companies depend on suppliers to a very large extent for the components, and TAFE is also like that. A good deal of our components are produced by our supply chain partners. And even the way we ensure quality is we have something called digital quality management system for our suppliers, where the suppliers' gauges are connected to a cloud, and we even do the process capability of the supplier even before the supplier unmounts a part from their own chuck or fixture. So we know the process capability much in advance, and we can flag off the supplier if part is right, or whether it's not acceptable, right? And similarly, all our processes, we use digitalized POKOs. If something, first of all, it prevents us from producing a bad quality part. And in case by mistake, if a bad quality is generated at any one of the workstations, then our assembly line wouldn't let us move to the next stage. So these are some of the concepts that we have very, very cleverly used in our own manufacturing systems to ensure robust product design, robust process design, so that eventually you get world-class tractor, right? So that has been my own experience with that. Now I would request some of the panelists to address certain interesting questions that we have come up with. And my first question would be to Sachin. So Sachin, see, like nowadays, the product design teams are constantly under pressure to introduce new products. See, the early days, you hardly get new products. Even in automotive field, you all know that Ambassador and Fiat, those who are old enough, they ruled the world. And those products have been around for almost like 30, 40 years without any single change in any of the tooling. And that's not the case now. For example, in our own organization, we have 300 plus SKUs, right? I mean, so, and all of them, I mean, most of them are live. So such proliferation of SKUs, which we are seeing. I mean, not only, I mean, it's not just a TAFE. I mean, any automotive or any other manufacturing field, you see one is you see more and more variety and more pressure to introduce new products, and the resources that were available earlier are not available in the same quantum nowadays. So, what are your views on this, Sachin, and how we can combat this issue successfully? Over to you, Sachin.
Thank you, Ashok sir, for this opportunity again. My roles and responsibility is to hear the voice of the customer. So what I probably will be mentioning is echoing their feedback from the customers. As you currently mentioned that the disruption of having a new product has gone into the each and every field. I could remember that electronics was one of the industry that put forth this disruption actually. And take an example of the mobiles actually, the way that are evaluating probably every 3 months or 6 months down the line, we will have a product, new launches coming up. And soon it was being followed into the automotive industry, and you experiencing it, how the products are going through that. And it's not getting restricted to the automobile industry, but it's getting into the appliances and other fields as well. They are equally following up. And you currently mentioned that has put a lot of pressure onto the designers and engineers and with the limited resources. Of course, they have to come out with the product in a much faster way. The shelf life has gone down from, say, probably like a 2 years. Now it has come to 1 year, or probably 8 months or 9 months or so on this. But when I discuss with the customers, they also say that few of the things are completely changed from last 20 years or so. Take an example, the way we design the products. Like going to some of the things that Arun mentioned in his presentation as well. AI is playing a very critical role over here, and to extent the CAD solutions are becoming more smarter. They are enabling the designers, the engineers, to to come up with the best design, and also avoid the repetitive steps that are happening in the design process. And saying so, they are equipped with much better tools than that was like a decade before or so. And now, further moving that, people are looking from the automation point of view. They want to add the algorithms to their existing process so that they can foster that design process also. And one of the things that, sir, you mentioned during the discussion is that organizations are adopting the best practices of like having a upfront validations so that they could avoid the challenges that will happen to the downstream manufacturing process. It could be related to the structurals, it could be related to the processes, and so. And I would say that design is, or the design phase is the most critical phase, and I hope that each of the panelists over here will answer that. 70 to 80% of the design decisions are being taken at the design stage. Could be related to the features, could be related to the form and functionalities, or could be related to the manufacturing, and you just mentioned on that as well. So a decade back, or like in 2 decades back, these things were not happening. And I would say that design, manufacturing, and processing were working in a silos, but they are now getting connected as well on this. So in that case, probably the manufacturing is also complementing to it, and they are also becoming a smarter. They are also adopting the AI in there, or machine learning, to avoid the repetitive steps. Sorry, I took a little bit of time, but yeah, I just thought of sharing my experience with the customers.
Brilliant. Thank you, Sachin. I mean, see, there is this concept of front loading the pain. The more and more you front load the pain in the design stage, and if you use the digital capabilities and automation, AI and ML, to execute a flawless design and flawless manufacturing process up front, I think a lot of issues downstream you can combat, and that way you can solve some of these challenges with all the capabilities that we now have, which we didn't have earlier. So thank you, Sachin. Now that I would really like to spend more time, but I mean, such an interesting topic. But to be fair, I have to get into the next question. So let me ask this question to Sandeep. Sandeep, again, this question is also again related to design. See, the concept of data-driven design, it seems to be in vogue mainly in the IT industry, and I'm just wondering, how, in your view, how this can be leveraged in the manufacturing industry segment, and how it can help us do things first time right. Over to you, Sandeep. Yeah.
Yes, Ashok. This is really interesting. The areas that IT industry uses, like say the cloud computing or big data analytics, or maybe the digital twins, of course, a part of AI or even VR. So all of these, they are taking slowly one step ahead in the real mechanical manufacturing per se, I'll say. Now, if you see the design, we always say that the value is created in the designs. And again, here what I'll say is that taking the things to the shop floor from design, there are a few areas like say digital twins. Now coming to the digital twins, which are generally used in various industries, we can have in-process twinning of the object, product, or the design itself, and the manufacturing teams can have the first level of assembly, second level of assembly, and then compare that with the design so that the things go errorless or flawless right in the beginning, so that the costs are saved in the rework and as well as in the area of the skills requirement. Now, as far as the skill takeover by the different areas which are used by IT industries. Like say there are certain areas which you already know, that the robotics. And the robotics, we know that the machine vision, like something like I'll take an example of welding. It's a lot of stress in spite of using those black glasses to the eyes. If it is taken over by the manufacturing, in the manufacturing, by the robots, the robot vision, it provides lot many advantages in the skill takeover part, so that we have very good quality which the robots can offer with a lot of consistency. So this is another area. Then what you can have as a big data analytics. Now, the pattern identification is one of the key areas in big data analysis, where the manufacturing teams can identify how the analytics can, the algorithms can find out the patterns of error generation, where the errors can occur, what are the typical process flows which can actually lead to these errors, which eventually become the cost of poor quality. So once these patterns are identified by these technologies, I think that can be very easy adoption in manufacturing, rather I'll say mechanical manufacturing, whether it's a process industry or a product that is immaterial. I think that is definitely having a lot of in manufacturing.
Okay. Thank you, sir. Thank you, Sandeep. Yeah, I'm a big fan of this process to twinning, where we compare the actual with ideal and using the data to identify patterns that can lead to error and how we can avoid it up front. That's a brilliant concept. I think we all need to see how we can do more and more of that. Right. So with that, I will ask the next question to Karthik. And Karthik, what machine learning and artificial intelligence related technologies have a chance to disrupt the industry in the coming years?
Yeah. What I think is, in my opinion, it's very difficult to predict one specific technology that would create disruption. But what I think is, it is possible multiple technologies will converge and create disruption in the coming years. So for example, let me talk about the 5G technology. So that was like a kind of mirage for us a few years ago. Now it's a reality, right? And similarly, if we see the computer systems, the computational speeds have gone up multifold, along with the data storage capabilities, right? And the availability of data itself, high quality data itself, has become very affordable these days for all of us, right? So all these technologies, I would say these are kind of enablers for a big artificial intelligence revolution that is going to take place maybe in the coming years. Maybe having said some technologies which I think that can possibly disrupt in the coming years could be reinforcement learning, which is a kind of branch of machine learning where you teach the system and work through feedbacks, which is widely used in robotics and games industry and also used in healthcare. And there are generative adversarial networks. Those are kind of deep learning algorithms that are being used in the neural network, and which is finding a lot of application in fashion and product development, prototype making. And the other technology, what I can think of is, let's say, natural language program. I don't know when was the last time we spoke to a human on the other side when we made a service call, right? Nowadays, we are talking to bots. So these kind of systems and technologies are also creating a lot of revolutions around customer service and healthcare industries and the associated families. Then like this, you have technologies like edge computing, right? So that is again gaining a lot of prominence in autonomous vehicles and smart homes and IoT devices and connected machines. And of course, there is one big technology which is kind of a sleeping giant. I would say it's called quantum computing. It is still in the very, very early stage of revolution, which deals with particles and molecules at a very, very subatomic level, which is going to create a lot of revolution in the drug industry, in the cryptographies and stuff like that. So overall, when I see the paradigm, right, so there is going to be a complete shift, and these technologies are expected to have significant impact on many industries in the coming years. And it is important for the organization to start exploring how they can be leveraged, so that we can stay competitive in business. Thank you. Thank you for the opportunity.
Thank you, Karthik. Yeah, some of these concepts, NLP, actually, it's very much in place. It has now become almost very, very prevalent. And rapid prototyping, it's all gaining more and more importance, making things easy. And quantum computing, absolutely, yes. Yeah, so you see, that has a chance to disrupt various industries, including fertilizers, drugs, chemicals. If we find a different way to do certain processes instead of what we have been doing for the last 100 years or 200 years, quantum computing can offer us some different way, more sustainable way to do things. Excellent. Thank you, Karthik. So now my next question will be to Vivek. Vivek, I have a question for you. So here, so you have some of these conventional operations, right? I mean, so you see, most of us are not starting from the ground zero, and there are operations or plans or technologies which are around. And how would you suggest taking such conventional operations to advanced manufacturing, and how will you plan for this transition? Over to you, Vivek.
Yeah, thanks. Yeah. So if you look, why the objective of taking conventional to advanced manufacturing, right? Finally, what we want to achieve? We want to achieve actually time, cost, quality. At the same time, now 3 S's come, right? Sustainability, scalability, and safety. These are very important things. And if you don't achieve these things, you can keep manufacturing product, but you will be behind competition and you will be obsolete in the market. So while working on all those things, it is very essential to meet all these 6 requirements. And that is the driving factor for taking your conventional manufacturing to advanced manufacturing. So when you look at advanced manufacturing, you will have a lot of technologies available, but you have to look for yourself. What is that for me, right? So what I would say to industry, since we work for many industry, giving the consulting, working for them. So what we generally suggest, or what OEM should do, is they have to identify their challenges first, right? They can find out the top 10 challenges and drill down to top 5 challenges. They should quantify their challenges. That is most important thing, because what we are seeing in the market, people are coming with some subjective issues, subjective pain areas, and they really don't quantify within themselves, and they try to ask the service providers or other vendors to give return on investment, because they could not able to compare unless and until they quantify the challenges. Next thing is, I would say, once you have challenges identified, right, you should have some vision to meet those challenges and where you want to go, right? So that vision, and with respect to that vision, you break down and create certain goals. And once you have those goals, you will be able to measure things, and then you have to bring the external consulting. I would definitely suggest external consulting firms to bring to the table, get their help, because they are having larger perspective of market, and they will be helping you to identify which technology will be suitable for you by mapping your as scenario, because mapping your as scenario is very important, and which technology is suitable, that is very important, because there are many technologies in the market, and with respect to your 5 top challenges, which technology will be suitable, then with the help of consulting firm or external body, you can create a detailed roadmap with the milestone, so that you will not go here and there. And while doing all those things, the moment you decide that you want to invest in going into advanced manufacturing, you have to bring a very important thing as a cultural change in your organization, because that's very important thing. Unless you bring that, or unless you start working for that, you cannot really make this thing successful. So cultural cultural change is very important. Once you have cultural change, because while mapping as a scenario, while suggesting something, your all stakeholder should be all with you. That's very important. And then we can create the implementation path, implementation journey. And while implementing, you will have a lot of challenges, but you have to understand it is coming because of what, how to mitigate the things, how to work on that. All those paths you have to go. And next thing is you have to continuously monitor where you're making progress, and you have to continuously measure. So these technologies are there, but what works for you, you have to identify, because your investment and time is very limited. And with that, you have to achieve goals. I would suggest that's the way to go.
Okay, thank you, Vivek. Yeah, see, so one point you also touched about sustainability. See, okay, companies now need to really focus on few things: energy, emission, reduction. I mean, reduction in consumption of materials, reducing or eliminating wastages, and conserving water. So, in addition to profitability or other market share challenges, these challenges are also real. And once you have a good idea about what these challenges are, you can develop vision, goals, then targets, and figure out what kind of plans you can put in place, what kind of cultural change, all the software aspects. So, yeah, it's a whole 9 yards which needs to be very carefully planned out, but it is certainly doable, as several organizations have demonstrated. Right. Thank you. With that, let me ask another related question to the question which is related to this question.
Sri, if we can have the second poll right now.
Thank you, Sujata. So like I said, my question is to Sunil. I just want to see, how do you justify advanced manufacturing? See, end of the day, see the organization. It's not like we are running a competition about who is using advanced manufacturing and getting some awards. End of the day, most of the businesses are for-profit business. So how do you dovetail your advanced manufacturing plans with the ROI expectations and justify? Any light you can throw on that, Sunil, on this kind of slightly a broader question?
So I think you have asked a very valid question, because the point is this: ki we all are engineers, and I think if given a chance or given a free hand, we all would like to go for a smart manufacturing, for the advanced manufacturing. But as you have rightly said, we are into business. Ultimately, any investment, any proposal, it has to show, we have to show the ROI, what the business is going to get, and why should we go about it. And that's the biggest question. And especially if you see, when we put any proposal for the advanced manufacturing, with respect to Indian context, definitely we get a lot of issues, because in India, the labor cost is much cheaper as compared to the Europe or America, where you may justify some of the advancement or smart manufacturing with respect to the manpower saving because of the manpower cost. But in India, it is very difficult to prove to management that yes, we are going to get this productivity improvement, and that is how this investment is justified. And that is why a lot of proposals get rejected, and that's the main thing. So what I think the best way is to justify for any advanced manufacturing investments is, first thing is, yes, definitely as a regular process, we all have to show the ROI, what is the total investment, what are the different cost advantage we are going to get, whether it is in terms of the productivity improvement, in quality, and the consumable cost, overhead cost, all other costing, anything that is directly related to the cost. So first part is, yes, we have to work it out. And I think the important part there, what we have to see nowadays, especially when we talk about the quality, and if we are putting some advanced manufacturing, which really we are 100% sure that there will be no defect generation will be there. So we all know today the cost of a single defect at the customer end. If there is a single defect at customer end, the kind of I'll say the management time, especially the top management time, and the middle management time for the review meetings, visiting the customers for justification, countermeasures. There's a huge, and if we take the indirect cost in account, especially when we are calculating for the ROIs, so that is also one of the very important factor. So I think that is one point which I would like to emphasize. Other important area is the intangible benefits. Normally, we always work out on ROIs, but at the same time, it is very important to show to the management what are the intangible benefits going forward for this advanced manufacturing. And the third important point I will say, actually, that is this is also one of the driving factors when we link the advanced manufacturing with respect to the group vision and goals. I think that also plays something, I will say, very important role with respect to any proposal when we are putting for the smart manufacturing or for the advanced manufacturing. We need to show the management with respect to the group vision and the goals that what we have set, competitors, especially what kind of technologies they are using, and then benchmarking with the world best technology or the world best, I'll say, the person who is in that product company. Then attainment of the competitive edge. If, for example, we are number 2 in any of the product in India or in the world, so if we would like to be number 1, then these are the ways we are going forward to achieve those positions. And then industry's leadership, for example, in a lot of products, in our case, for example, in a lot of products, we are number 1 in India. So if we have to maintain our leadership, yes, definitely we have to be the first mover in the industry. So this is my takeaway, because whenever we make any proposal, we put these 3 points in front of the management. First is the direct benefits. Yes, those are all the financial things that what we are going to justify. Other thing is the non-tangible benefits, and third is the strategic movement. How we will be moving from one level to the another level with respect to our competitor. How will we moving closer to our vision and goals.
Thank you, Sunil. Yeah, especially if there is someone out there making world-class products using some of these digitalization and advanced technologies, and one can't match that with conventional operations. So so one is obviously you get better quality, even whether the ROI is financially is there or not immediately, but ROI will be there. There's always an incentive for better quality. And what I also see more importantly is you are de-skilling your operation with such automation. So you are reducing the dependence. Nowadays getting skilled personnel is becoming difficult. So you're reducing that dependence. You're removing that bottleneck. So that's also another charming reason, in addition to all the other indirect benefits that you've mentioned. So let me ask my next question to Gajendra. Gajendra, see, SABs have been around for as long as I can think. Sorry. Hey guys, could somebody go on mute? Those who are not speaking, if you can go on mute. Okay. So how we can leverage existing ERP investments to monitor our operations and how to improve. In other words, how you make the already smart ERP systems even smarter. That's my question to you.
Actually, this present manufacturing industry, where we are making transformer or machines and equipment, both are the handle the manual operations. So in demand of the management is presently, they want to capture more and more data related to productivity, related to the efficiency of the manpower, related to the efficiency of machines itself in terms of power consumption, everything. So they want the monitoring system to online. So we have some digitalization in our manufacturing plants, where we can put some tab or some digital instrument directly on the machine, which can directly link to the ERP system. So the workers and the technicians or the operators working on the machine can enter directly the information related to their productivity, related to the machine consumption, power meter from meters, they can directly enter into the step. So each machine and each workstation need to be digitalized accordingly to capture the data, and that digital information with the help of clouds can directly be linked with the ERP system. This is the whole idea for the digitalization of manufacturing to improve the efficiency. So this is the whole idea actually.
Okay. Okay. Thank you, Gajendra. See, I mean, it's not only about power consumption and other aspects. Nowadays, the sustainability also becomes very, very important. See, a lot of, all the regulators like Pollution Control Board, they are now insisting on monitoring the effluent parameters and also transmitting the data live to their headquarters. Whether it's pollution or somebody who has stack like SOx, NOx emission or effluent, right? I mean pH and COD, BOD, all those parameters. So more one is such requirements are coming, and then once you acquire such digital data, you can also have some algorithms to look into that and see how we can use some of the predictive measures to foresee problems before they happen. Okay, so with that, now so I think we are done with one round of questions, and now let's do our next round, and then we will go into Q&A. Okay, so now my next question is to Karthik. Karthik, I think we briefly touched upon this particular question earlier, but I would like to slightly elaborate on that one. See, now with the hybrid manufacturing, whether it's how do you think it can be adapted? So when I say hybrid, we have both additive, which is the new stuff, and the subtractive, which is the conventional. How they all can be dovetailed with each other, and so that we can get synergies. Over to you, Karthik.
Yeah. Thank you, Ashok. Again, hybrid manufacturing, as you rightly said, it combines the technology of additive manufacturing and the subtractive manufacturing process, right? So what we see is there is a very increasing trend nowadays in terms of its adoption levels, especially in industries like aerospace, automotive, and medical. This is primarily because with additive manufacturing, you gain a lot of flexibility in terms of production of the complex parts, which otherwise cannot be manufactured in the traditional routes. And also, you're able to produce the parts with certain level of precision and accuracy, which also eliminates, as Ashok, you said in the beginning, reduction of material waste and reduction of lead times, right, which is very important. Recently, when I saw a memo, it was like a very interesting machine, which was displayed by one of the machine tool builder, wherein in the same machine, he had the technology of additive manufacturing and subtractive manufacturing process integrated, right? So that was like, imagine what kind of opportunities it is going to throw up for the entire world, right? I mean, imagine a process where you're going to hold a workpiece without changing its position. You're going to build the workpiece in the same position, and you're going to manufacture or do the subtractive manufacturing process without even removing the workpiece from its position, from its station. So you build the workpiece, and then you do the subtractive machining process to get the finishing, to get the accuracies. And this was like very fascinating. This was like, I mean, amazing technology, which I saw. I mean, imagine today, okay, it might be a little bit on the cost side. Yes, it might be very expensive, but once the scale of production and the adoption level increases in the market, I think it is going to offer a lot of flexibility for all of us. So what we do in Kennametal is also nowadays some of the complex tools. What we manufacture in Kennametal, they are actually printed parts. They're actually manufactured through this hybrid technology and 3D printing. So one of the part, if I can recollect, it is the stator board for the electric vehicles. For the electric cars, you have the stator motors and you have the stator housings, right? So for that, we made tools which are very complex and which also had the 3D printing technology, and also it had a fusion of dissimilar materials in order to reduce the weight, etc. So it was a super complex tool, but it was made to work in a very low pass spindle. So that was the design and the capability which we had. Obviously, it had resulted in better performance and improved throughput for the customer. So what I see is it is not one technology which will kind of supersede the other technology, but in my opinion, both hybrid and subtractive manufacturing process will coexist. Mm-hmm. I go back to what Sunil said. Finally, it is the ROI and the other factors in terms of tangible benefits, intangible benefits, and how well it will fit into your strategy. That those aspects also becomes very critical when the investment scale becomes bigger, right? But these kind of technologies are evolving, and we are going to see a lot of fascinating stuffs in the future.
Wonderful. Yeah, that's how you synergize what's out there and what new stuff are coming. And especially I like the concept about not taking the part from the machine and going and making most of your manufacturing so that your datum, everything remains intact, right? Instead of moving around. So even geometrically, that goes a long way. Thank you, Karthik. My next question is to Sachin. Sachin, how can we bridge the gap between discrete workflow from design and manufacturing? And what are your views on this? And what are your recommendations, Sachin?
Thank you, sir. I would say that, let me share my experience when I started my career. And when we used to do like a design and then follow the manufacturing, there was always been a disconnect actually in terms of what we design and what the product we used to get it. But let me, give a little background of that. Whether you are a designer, you're a production manager or a quality manager, each of you or each of us is responsible to get a right product in hands of the customer. If you don't get it, probably, some of the panels mentioned that customer would definitely throw it back to us on this one. But saying so, each of the person over here, like a designer or a production manager or a quality, has their responsibilities and they are equipped with their expertise to do so. Let me give an example again with take an example like a designer. They would be interested into the aesthetics of the part, the fit and form of the functions of the part on this one. But downside of somewhere that creates a disconnect is they are unable to understand some point of time. I'm not saying each and everyone, but understand that how the manufacturing is going to happen on this one. And that really creates a gap between like what we design and how it is going to manufacture. But these challenges are not new and people are trying to get over to it. Like, by implementation, some of the things that you sir mentioned is on like having a upfront simulation where they give a fair idea of how the process is going to happen and probably the challenges that is going to occur. And if design has the flaws, it gets, its magnitude wise, it gets amplifies much larger as it goes from the design, tool manufacturing to the production and so. And I've also seen that many of the companies, they struggle to retrieve the data. Probably like in the component which has been manufactured like in 2 years back, and if they come with a repetitive same component, I still see that they go through the folders and so. I'm not saying that it is true for each one, but I've seen that it's happening, and that creates a gap, like what we have done last time, what best practices which was adopted, we lose them. And probably having a data at one locations or retrieving of data is very important part of it on saying so. And one more thing before I conclude is that, and fellow panelists, they discuss on to the having a smarter manufacturing technology, and Karthik sir did mention on that of having a hybrid technologies, having it. So just not having the way we are designing or way we are manufacturing, industry should also look for what's upcoming technology and start investing on this one. I'll give an example of like having a conformal cooling in the tooling aspects. It has a lot of merits, but this technology is still an expensive thing. But I have seen that the organization who understands the benefit of it, they have going ahead and doing the investments on this. And to an extent, this is just helping, bridging a gap. The complex product that are designed are also getting manufactured as it is with these technologies.
Thank you, Sachin, for this elaborate answer. So maybe in the interest of time, I just want to ask one last question, and then we will go into Q&A. This question I would ask Vivek. Vivek, there are always conventional topics such, or some very, very proven concepts rather, like TQM, TPM, Lean, and all that stuff. Wonderful stuff which has served us very well in the last 30 to 40 years. But now with all these AI and ML predictive analytics coming in, how would you continue to leverage the power of these concepts that were developed earlier, but how would you also ensure that this AI, ML, and all those things are helping us pursue those concepts because they are evergreen? But how do you leverage these capabilities to further intensify your efforts and get more results of these manufacturing excellence pursuits? Over to you, Vivek.
Yeah, so if you look at these concepts, right, TPM, total quality management, total productive maintenance, lean manufacturing. So these are, if you look at these concepts are widely used in the manufacturing industry. They are proven, everybody is using. But one thing, what they're lagging is real-time monitoring is not there. Okay, so what happens? It all depends on like human skill. To identify the gaps, human is required. At the same time, to implement those things, you need human. Whereas if you get the help in terms of real-time data, real-time monitoring, then things will be a bit easy for you. Okay, and somebody wants to start journey in this direction, they should not leave this. These are very important because without which no manufacturing industry will survive. It's very important things which are already proven, and we should implement that. So I would say who are going in this journey and trying to take benefit of this next level technology, they should see few of the things which are in between, like plant simulation techniques, where it has inbuilt AI is there to create multiple scenarios for various areas. It could be from anything. You can look for process, you can look for process, you can look for various material flow related options. So those things you can adopt using plant simulation. So other thing we can look at it by adopting this. You can use it for cost of poor quality in terms of quality. At the same time, you can improve your PFMEA or reliability by enhancing this technology by taking help of some new technologies like AI, ML, and predictive analytics. So in a nutshell, to close this, I would say three things all the industries or those who want to get into the journey, they should do. Like TLP model, what we generally call, like train in at least 3 areas, your key resources, then learn to apply, which is help. Minimum 2 case example, which could be from other industry, which will fit to your industry, but they should know detailed know-how of it. And at least one area they must practice. So if you apply this TLP model, which is 3-2-1, actually you'll really go along with this technology by using IML and other analytics data. So that is what I would say.
Thank you, Vivek. I think so. So by and large, I mean, these concepts are evergreen. So take the concepts, take the goals, and the means. You see how you can leverage, the modern day stuff like AI, ML, right? I mean, so in fact, that's how I would also put it. Okay, so maybe I will just ask one last question, if okay with Sujata. Maybe we can just go with one more question and then open the floor for questions. Right? Will that be okay, Sujata?
Yeah,
right,
that's fine.
Okay, thank you. So my last question is to Sunil. Sunil, we discussed a lot about the quality, productivity, cost, and so on and so forth. That advanced manufacturing will help us bring in. But a couple of other very important matrices I would like to add is how this advanced manufacturing will help us in terms of one is internally, which is safety, how it will help us be even more safer organization than where we are. And other is how it will help us improve the customer centricity. So over to you, Sunil.
I think if I will talk about our journey towards the smart manufacturing, so we have actually invested almost around 2 CR last 3 years back with an ROI. We are expecting that it will be there in 18 months. Uh, Unfortunately, yes, there has been some delays, but that's the good part that we have been able to achieve our ROI in 24 months. So now, as what you have been talking about, so we have actually also, when we were designing the process that we have to go for a smart manufacturing, so we thought that what will be the areas where we will be working on. So we have selected first is the productivity, because that is the main thing which will be actually justifying the ROIs. Second is the energy. So that is also a cost term which will be helping us to invest that money. Then material point of view, so material cost reduction, and then quality point of view, that what you are talking about, that how it is we were able to give a better quality to our customers. And then the delivery front, so customer side issues with respect to delivery, how are we going to resolve those issues? So considering these 4 or 5 areas, we have actually implemented the smart manufacturing in our plant. And with respect to that, what I would like to say that first is, yes, we have been able to give a good saving, because management is basically focused on the saving that what you will bring on the table. So we have been able to do a material cost reduction of almost around 1%. Similarly, the labor cost reduction of around 15%. Overhead cost reduction is around 12%. Then energy and utility cost reduction of about 2%, and tooling and spare cost 2%, and reduction in working capital is almost around 1%. So these are the results which we have been able to achieve. And with respect to the quality concerns at the customer end, so I think I will be happy to share with you after the implementation of smart manufacturing at our plant, almost for around now it is almost 18 months that we have a zero defect at our customer end, because we have tried to interlink all our processes. So if there is any issue at one of the process, it get detected at the next process. So for last 18 months, we have been at zero defect. And with respect to the delivery perspective also, so we are almost 100% in delivery and maintaining a #1 position at our customer. So these are the results that what we have got after implementation of this part.
Thank you, Sunil. In fact, one of the charming areas where I felt with this advanced manufacturing is safety. See, for example, when we automated one of our paint shops with robotic painting,
Yeah.
we didn't have to have people there. So, the machines can do the hard stuff, not the people. And as you also mentioned, the consistency of a machine produced part is always pretty good. So customer complaints are drastically reduced. So with that, I think we will conclude this panel, and then now we will open the floor for questions. Anything from you, Sujata? You want to add anything?
Yeah. I just want to thank you, Ashok, for wonderfully moderating this specific and very pertinent topic. And thank you to all the panel members for sharing your deep insights and sharing the case studies as well, and being a part of this conversation. So before I open the floor for Q&A, we will go for the final poll. Sri, if you can share the polls, please. Okay, we'll be sharing all the poll results with all the panel members and with Autodesk. So now moving on to the questions, we have a question for Sachin. Does Autodesk support in making simulations for project-based companies on a case-to-case basis?
Thank you, Sujata, for that question. Autodesk, being a product company, we all work very closely with our customer for the implementation point of view. But saying so, on to the project basis, we do have a consulting team at Autodesk who works on turnkey projects. But on case basis, probably we have a equally equipped channel team as well. So probably our partners who also work along with us for the implementation of the solutions can be the best one to reach out to us. But yeah, saying so, if you need any help on reaching out to our channel partners and helping on the project basis, we can work with you on that.
So the next question is, will it be a threat to manpower because of the development in AI and ML technology and smart manufacturing? Anyone willing to take the question?
This was a very interesting question that people do ask, that whether people are going to lose jobs or whether there will be unemployment or kind of things. The principles of automation are switching with respect to industry from industry 4.0 to 5.0, and where the 5.0 is becoming more sustainable and human centric. Now the key question that everyone needs to ask is how he will reskill himself to be in the process. And the reskilling itself means, there was an example going on sometimes back about how the design plays a role. Now, early days, I remember that the programs on CNC machines, they were either fed by pressing keys, where the skills were there on the shop floors. Later on, the connecting systems came in, and the skills moved to the communication people. The skills with the seamless communication, or the kind of communication that we have between the design and the direct adoption of the algos in design directly on the machine language. Now it has switched to the design teams or engineering teams. And I think that one should not be absolutely afraid about how the technology takes over. It takes over with a lot of benefits, because human centricity, sustainability, these are the key aspects of the world. Because if there are no consumers, then the development, the cost saving, the high speed or the deliveries, they are not going to really matter. And the world knows this. And there are so many drives going around in the world, and the Western world is working very hard on this industry 5.0. So please don't worry about that. That's from my side. Karthik, you can add to it. Thank you.
I just wanted to add to Sandeep. Actually, any technology, if you take for that matter, which is going to save time and human effort without compromising safety, that will exist. Whether we like it or not, that will take over. So artificial intelligence is in that direction. So it is, as I said before, it is going to have a lot of convergence of technologies, which is going to take place in the near future. All these things will play a very vital role in terms of reducing the human effort and saving human time. Any technology which is going to play a very underlining role into these things, it will exist, and it will take further, shapes in the near future.
Okay, this is like, few days back when there was a post which was going around when the teachers were out on the street protesting the calculator back in 1970s, when it was kind of becoming very prominent, and then now it is ChatGPT. So the next question is to you, Karthik. For material of product standpoint, how this digitization or advanced manufacturing process is helping in R&D phase, apart from the SCADA and other technologies which are used in weighing or measurement?
See, material technology is also undergoing a rapid change, I would say. I mean, if you see the industries, one of the industries is obviously the aerospace industry, where materials are undergoing a rapid change, rapid transformation. I mean, olden days, more of aluminum, now it is moving into titanium and CFRPs. Products are being made with a lot of, care, and manufacturers, they want the products to be more durable, and at the same time, it should have less weight, and it should yield better performance. So what I think is definitely the material science as a stream itself is evolving continuously, and artificial intelligence will play a very important role in terms of shaping the material science stream to a completely different level, especially when I talk about industries like aerospace, medical, dental, right? Especially the dental implants that we see today. This is undergoing a lot of transformational changes, right? So I don't know whether I've answered the question correctly, but the materials are going to have some rapid change for sure in the near future.
So that's all in Q&A as of now. If audience have any more questions, do feel free to write to us. We will be sharing these questions with our panel members. Thank you all for those who have logged on to be in a part of this webinar. I really hope that the insights have been helpful. And thank you all the panel members who have taken time off your busy schedules and being a part of this webinar. Thank you, everyone.